required to continue the motion. Okay, so if mk is the mass of the kth particle, wk is the acceleration, fk is the effective force, and rk is the reaction force, then the general equation of dynamics is mkwk is equal to fk plus rk. Here all the constraints considered are the ideal constraints, so the equation number 2 will be satisfied, that summation k from 1 to n rk del rk will be equal to 0. Now from equation 1 obtain the value of rk. It will be fk minus mkwk, and replace that very value in equation number 2. So we obtained the equation number 3, and it becomes summation k from 1 to capital N fk minus mkwk del rk is equal to 0. This is termed as the general equation of dynamics, or equation 1 and 2 can be considered as the general equation of dynamics. Now let's derive the Lagrange equation of first kind. Initially it is written that, okay, we are assuming that a constraint system is given, mk is the mass of the kth particle, wk is acceleration, fk rk are the effective and result reaction forces respectively. So we will have, due to the constraint system, equation number 1 will exist, that mkwk will be equal to fk plus rk. Now we are to obtain the reaction forces. Also the equations for the virtual displacement were as obtained yesterday, summation k from 1 to capital N curly f alpha by curly rk del rk equal to 0, where alpha lies between 1 to d, and summation k from 1 to capital N L beta k del rk is equal to 0, where beta lies from 1 to g. Now just do one thing, multiply equation number 2 with minus lambda alpha and equation number 3 with minus mu beta, and then add those equations in equation number 1. Okay, or sorry, all the constraints are ideal, so we will have summation k from 1 to capital N rk del rk is equal to 0. Now do that thing, means multiply equations number 2 with minus lambda alpha, equation number 3 with minus mu beta, and then add to equation number 4. What will happen? We will have equation number 5. In all the three equations, one term is common, summation k from 1 to capital N. So that is taken common. Then in equation number 4, we are having rk. From equation number 2, we will have minus lambda alpha curly f alpha by curly rk. But alpha lies from 1 to d. So all the values are placed, and we are having summation alpha from 1 to d lambda alpha curly f alpha by curly rk. Then from equation number 3, we will have minus mu beta L beta k, but beta lies from 1 to g, so we will have a summation beta from 1 to g mu beta L beta k del rk is equal to 0. Now expanding this into the Cartesian equations, we will have the coordinates of x, y, and z. So we will have summation k from 1 to capital N rkx minus summation alpha from 1 to d lambda alpha curly f alpha by curly xk. As we discussed earlier, rk is rkx I cap, rky j cap, rkz k cap. Curly f alpha by curly rk will be curly f alpha by curly xk I cap plus curly f alpha by curly yk j cap plus curly f alpha by curly zk k cap. And similarly, L beta k is A beta k plus B beta k plus C beta k, and ijk are correspondingly. So we termed all these terms in the Cartesian coordinates and obtained the equation number 6. Now in equation number 6, we are having a linear combination that is equal to 0, and this linear combination involves delta xk, delta yk, and delta zk. But xk, yk, zk, these are the independent coordinates. And since these are the independent coordinates, therefore in the combination the scalar quantities will be equal to 0. Therefore all these brackets rkx minus summation, all these terms will be 0. So we will have equation number 7, rkx minus summation equal to 0, rky and rkz. From equation number 7, we can obtain the values of rkx, rky and rkz. Okay, so all the values are obtained, and then those values are replaced, multiplying the value of rkx with I cap, rky with j cap and rkz with k cap, and then adding, we will have rk vector minus summation alpha from 1 to d lambda alpha curly f alpha by curly rk minus summation beta from 1 to g mu beta l beta k is equal to 0. From here we can obtain equation number 8, which involves the value of rk vector.
सर
Yes.
सर कुछ बच्चों की मीटिंग ज्वाइन नहीं हो रही.
Okay, let me allow them. Say them that they should try again.
सर आपने पढ़ाना स्टार्ट कर दिया ना, इस वजह से नहीं हो रही शायद उनकी.
कोई नहीं, उनको दोबारा कहो कि एक बार ज्वाइन करें दोबारा.
ओके सर.
Okay, let me repeat it again. A quick review. Basically, we people are going to derive the Lagrange equation of first kind. Okay, and to derive that, yesterday we obtained that if some system of particles is given and mk is the mass of the kth particle, wk is its acceleration, fk is the effective force, and rk is the reaction force, then the equation for dynamics is mkwk, or the equation for possible acceleration is mkwk is equal to fk plus rk. Okay, after that we assumed the we considered the equations for virtual displacement that we obtained yesterday. The equations were summation k from 1 to capital N curly f alpha by curly rk del rk is equal to 0, and summation beta from k from 1 to capital N L beta k del rk is equal to 0. Alpha lies from 1 to d and beta lies from 1 to g. Also, we considered all the constraints to be ideal. So, the work done of reaction forces over virtual displacements will be 0. Thus, we are having the equation number 4. Summation k from 1 to capital N rk del rk is equal to 0. Now, we are going to use the method of Lagrange multipliers. you people discussed in mathematical analysis also that method. We are just multiplying equation number 2 with minus lambda alpha and equation number 3 in minus mu beta, and then adding all these terms in equation number 4. So we will have summation k from 1 to capital N Rk minus when equation number 2 is multiplied with minus lambda alpha, since alpha lies from 1 to d, so we will have the summation alpha from 1 to d lambda alpha curly f alpha by curly Rk. Again, equation number 3 is multiplied with minus mu beta, and beta lies from 1 to g. Thus, in equation number 5, we are having the summation beta from 1 to g mu beta L beta k into del Rk is equal to 0. Okay, now explain this term into the Cartesian coordinates. So we are having dot product of two vector quantities, one inside the bracket and second del Rk. So we will have Rkx minus summation alpha from 1 to d lambda alpha curly f alpha by curly xk minus summation beta from 1 to g mu beta a beta k del xk. Similarly, the y components and similarly the z components equal to 0. Now, these del x cage, y cage and z cage are the independent quantities. And this is a combination that is equal to 0. So, all the terms, all the scalar quantities will be equal to 0. Therefore, Rkx minus summation alpha from 1 to d lambda alpha curly f alpha by curly xk minus summation beta from 1 to g mu beta a beta k is equal to 0. Similarly, y component is 0. Similarly, z component is 0. Now, multiplying the first term in equation number 7 with I cap, second term with I cap, and third term with A cap, and then adding, we will have Rkx I cap plus Rky j cap plus Rkz k cap. It is Rk vector minus summation alpha from 1 to d lambda alpha, and then this term will be curly f alpha by curly Rk, and the last term will be summation beta from 1 to g mu beta L beta k. So we have equation number 8. It is the value of Rk vector. Now replacing this value into equation number 1, the equation number 1 will become mkwk is equal to fk, this is the effective force, plus summation alpha from 1 to d lambda alpha curly f alpha by curly Rk plus summation beta from 1 to g mu beta L beta k vector is. That's all for k from 1 to n. And this very equation number 9 is known as the Lagrange equation of first kind. Okay, the constraints, all of you know, were considered to be the finite constraints and the differential constraints, d finite and g differential. Oh, sorry. Okay, so in equation number 9, we are having the Lagrange equation of first kind. Keep it in mind, all the equations that are finite are given will be used. The first summation alpha from 1 to d, it is for the due to the finite constraints, and the second summation, that is beta from 1 to j, it is for the differential constraints. L beta k is the coefficient of the velocity, the kth velocity component. Curly f alpha by curly Rk, it is the velocity component from the finite constraint. Okay, let's start. We are going to discuss an example, and with the after that you will get the idea that how to use these equations. For the example, we are given with two ponderable particles m1 and m2. Both are having identical mass, that is 1 unit. Okay, joined by a rod of invariable length L and negligible small mass. The system is constrained to move in a vertical plane only in such a manner that the velocity of the midpoint of the rod is directed along it. We have to find out the motion. We discussed this example earlier also, and in that Gaurav asked some questions. Okay, you can find out that how the constraint equations are obtained in that lecture. I have shared that video also. What is given? Two particles are attached at the ends of the rod. Length of the rod is L, and this rod is moving in the vertical plane in such a way that the velocity of the midpoint is in the direction of the rod. Sorry. So the constraint equations will be, the first constraint is finite constraint and it is the length of the rod. So it will be x2 minus x1 square plus y2 minus y1 square is equal to L square. We brought L square on the left hand side and then multiplied with 1 by 2. It hardly matters. The second constraint was x1 dot plus x2 dot upon y1 dot plus y2 dot is equal to x2 minus x1 upon y2 minus y1. Cross multiplying and then placing all the terms on left hand side, we obtained x2 minus x1 into y2 dot plus y1 dot minus x2 dot plus x1 dot into y2 minus y1 is equal to 0. Okay, the Lagrange equation, it was this one, mk wk is equal to fk plus summation alpha from 1 to d lambda alpha curly f alpha by curly rk plus summation beta from 1 to g mu beta L beta k. And now we are going to derive the equations in our case. I want your attention because how to use it, it is the most important thing. First of all, in our situation, we are having only one finite constraint. So the first summation alpha from 1 to d, it will be alpha from 1 to 1, means it will be lambda 1 curly f1 by curly rk vector. Also, we are having only one differential constraint, so the value of g is also 1. So we will have plus summation mu1, no summation mu1 L1k. Okay, now let's find out equation number 4. In our given conditions, the mass of both the particles is 1. So the value of mk is 1. Okay. Just look at equation number 3. We will find out all the possibilities from equation number 3 and we will obtain the values of equation number 4. The equations in 4. First of all, on left hand side, mk, these are 1. Okay. Now, on left hand side, we are having only the acceleration components. And we are having 4 coordinates, x1, x2, y1, y2. So there will be 4 components for acceleration. x1 double dot, x2 double dot, y1 double dot, y2 double dot. Double dot represents double derivative with respect to t. First derivative represents the velocity and second derivative represents the acceleration. Okay, first we are going with the coordinate x1. x1. So on left hand side in the first equation we are having x1 double dot. Okay, now move to the right hand side. On right hand side the first term is effective force. Now we are having two axes, x-axis and y-axis. X-axis is the horizontal one and y-axis is the vertical one, and it is given that the motion is in the vertical plane. So the force along x-axis, there is no effective force, because if there is any effective force along x-axis, then the motion cannot be in the vertical plane. So along x-axis there is no any effective force. So in this case Fk is 0 for the first equation. Now plus lambda, I'm not saying lambda 1 and mu 1 because we are having only one coordinate, so lambda and mu will be used. So we will have lambda, and now the partial derivative of the finite constraint with respect to the coordinate means the partial derivative of equation number 1 with respect to x1. It will be 1 by 2 into 2 times x2 minus x1 and minus outside due to x1. So it will be minus x2 minus x1. And thus we have minus lambda x2 minus x1. plus mu into the component of velocity component, means the component of x1 dot in equation number 2, and in equation number 2 the component of x1 dot is minus y2 minus y1, so it is minus mu y2 minus y1. If it is clear to you people the first equation, then can we proceed further? And if you have any doubt, you can ask. Anyone have any doubt? Okay, then I am assuming that everything is clear. Now I am going to second 4. It is for y1 coordinate. So on left hand side the acceleration component is there, y1 double dot is equal to, now the motion is in vertical plane and gravitation attracts downward. Force is the gravitational force in the negative side, so it is minus g. And now the same procedure, plus lambda into partial derivative of finite constraint with respect to y1, it will be minus y1, and then plus mu into the velocity component of y1, it is x2 minus x1, so we are having plus mu into x2 minus x1, and this is equation number 4. In the similar pattern, the equation number 5 means the for x2 and y2 components. On left hand side we are having x2 double dot, again x-axis, so there is no effective force, plus lambda into partial derivative of finite constraint with respect to x2. This time it will be x2 minus x1, so we are having lambda into x2 minus x1 minus mu into y2 minus y1. I think it can be obtained by you people. Okay, now arranging all the terms on left hand side of 4 and 5, we will have equation 6, 7, and then from equation 6 and 7 we have just arranged the terms of equation number 4. From equation number 4, these are two equations and we are having lambda and mu. We can obtain the values of lambda and mu. So from equation 6 and 7, to obtain the value of lambda, just multiply equation number 6 with x2 minus x1 and 7 with y2 minus y1. We obtained equation number 8. However, in the denominator we are having minus x2 minus x1 square minus y2 minus y1 square. From equation number 1, it is minus L square, because it is the distance between the coordinates and that is the length of the rod. Okay, again multiply equation number 6 with y2 minus y1 and 7 with x2 minus x1, and then subtracting we will obtain the value of mu. Okay, then lambda is given using the equation number 1. Similarly, we obtained the value of mu, and also from equation number 5, if we will observe in equation number 4, if we will replace lambda by minus lambda, we obtain the equation number 5, x1 double dot y1 double dot with x2 double dot y2 double dot. So from equation number 5, values of lambda and mu can be obtained as equation number 11 and 12. Now we have values of lambda and mu, but two values of lambda and two values of mu. In equation number 9 and 11, we are having values of lambda, and in equation number 10 and 12, we are having value of mu. Equating both these values, the values of lambda and the values of mu, we will have equation number 13 and 14. Some terms will be cancelled, and finally we will have equation number 13 and 14. Now we are going to define 4 terms. One is u, x2 minus x1, v, y2 minus y1, p, x1 dot plus x2 dot and q y1 dot plus y2 dot. Then equation number 1, it was x2 minus x1 square plus y2 minus y1 square equal to L square. So it is u square plus v square is equal to L square. Then equation number 2, that will become PV minus QU is equal to 0. Equation number 13, sorry, it is x2 double dot minus x1 double dot. So it is u double dot into v minus v double dot into u is equal to 0. Equation number 18 is obtained. And from equation number 14, it is p dot u plus q dot v plus 2gv is equal to 0. Okay, so we are having equation number 16, 17, 18 and 19. And now from equation number 16, we can conclude that u square plus v square equal to L square. It's the equation of a circle having radius L. So we will conclude that the motion is in circular motion. It's a circular motion. And also from equation number 18, we observed that u double dot upon v double dot is equal to u by v, means the ratio of the acceleration is equal to the ratio of the coordinates, means the motion is uniform. Motion is circular and uniform. So due to the circular one, we use the what we will say polar coordinates. U is equal to L cos phi, v is equal to L sin phi. And now, since the motion is uniform, means the rate of change of the angle is uniform. So phi dot will be equal to alpha, some constant, the rate of change of angle. From here, integrating, we will obtain phi is equal to alpha t plus beta. Is it okay? Also, from equation number 17, P is equal to Q by V into V, U. From equation number 17, value of P will be Q by V into U, and value of Q, it will be P by U into V. Okay, so we are just assuming a F with the property that P is equal to F by L into U and Q is equal to F by L into V. This F will be designed later on. Up to now, we don't know what F will be. But replacing P and Q, U and V in equation number 19, we will have F into U dot U plus U square F dot plus F into V dot V plus V square F dot plus 2G VL is equal to 0. Now replacing the values of L cos phi and L sin phi, we will have F into minus L sin phi and then U dot L cos phi and then derivative of phi, that will be alpha. So this equation is obtained. In this we are having two terms cancelled and two terms involving sin square plus cos square, that will be 1. So F dot is minus 2G sin phi. This is F dot. It means now dF by d phi, it will be dF by dt upon d phi by dt. dF by dt is minus 2G sin phi and d phi by dt, it is alpha. So dF by d phi, it will be equal to minus 2G upon alpha sin phi, multiplying both sides by d phi and then integrating, we will have F is equal to 2G by alpha cos phi plus 2 gamma. This is F that we said that it will be discussed later on. Now replacing the value of F in P and Q, we will have P is equal to this quantity and P is x1 dot plus x2 dot and Q is equal to value of F into V. It is this quantity, that is y1 dot plus y2 dot. Now we are having the values of x1 dot plus x2 dot and y1 dot plus y2 dot. Integrating these two with respect to t, from equation number 10 x1 plus x2, from 28 we will obtain y1 plus y2. I think you can obtain the value of this integration. Also these are x1 plus x2 and y1 plus y2. Further, what is u? U is L cos phi, and we defined u is equal to x2 minus x1, means x2 minus x1 is L cos phi, y2 minus y1 is L sin phi. Now we are having 4 subtracting, we can obtain the values of x1, x2, y1 and y2 as these 4 values 31, 32, 33 and 34, where phi is alpha t plus beta, and so the motion is obtained. Okay, you should read it. If you will find out any problem, we will discuss it tomorrow.
Okay, sir.
Okay.
सर ये रिकॉर्डेड लेक्चर शेयर नहीं करोगे आप?
कर रहा हूँ बच्चे, मैं तो डेली करता हूँ।
तो रिकॉर्डिंग शेयर नहीं करते
बच्चे गूगल क्लासरूम को चेक करो, डेली रिकॉर्डिंग